All right, so let's get started with this first mock exam paper that we have for theory. All right, so the name is Ahmed Bokhari. And of course, we'll mark it and write our time at the end. Choose from the following oxides to answer the question. Okay, so before we delve into this, a couple of things that we need to remember is that oxides can be acidic or basic or neutral or amphoteric, 4 different kinds, but it's all related to metals and non-metals. So metal oxides are predominantly basic, but some of them are amphoteric, and the amphoteric ones are aluminum, zinc, chromium. Similarly, for non-metals, you have neutral and acidic, and the ones that are neutral are nitrogen monoxide, water, and carbon monoxide. So this is a rough tree that helps us understand some of these questions. All right, so let's move on. Has a simple molecular structure. Simple molecular structure implies it's a non-metal oxide, so that should be sulfur dioxide. Now, you can write formula or you can write the name because they did not specify whether you name it or whether you write the formula. You just have to state. Is a colorless solid. Colorless solid means that, colored solid. It's a colored solid, so that would mean it has transition metal ions in them. So that should be iron 2 oxide. Contains ions with +3, that is aluminum oxide. Now don't write aluminum only. Write the whole aluminum oxide thing because we need to know which oxide has +3 charge in it. An ion with +3 charge. Product of thermal decomposition of calcium carbonate, that's pretty straightforward. Carbonates break down to give carbon dioxide and oxide. So this must be calcium oxide. Contributes to acid rain. We have already seen sulfur dioxide and that is the one. So sulfur dioxide. Dry air contains nitrogen, oxygen, noble gases, and carbon dioxide. State the percentage of oxygen, so that is 21%. IGCSE people can also write 20%. Carbon dioxide is removed from a sample of air by passing it through sodium hydroxide. Because carbon dioxide is acidic, it will react with sodium hydroxide and neutralize it. Okay, so that's what the question is. Explain why aqueous sodium hydroxide removes carbon dioxide. So we'll say that CO2 is acidic and reacts with sodium hydroxide, which is alkali, or neutralizes it or something like that. So reacts with aqueous NaOH, which is an alkali. Describe how oxygen, nitrogen, and noble gas are separate from each other. So obviously that is fractional distillation by first liquefying the air. So it is liquefied. That's important because we need to first liquefy it, get a mixture in liquid form, then slowly heat it. Gases are separated based on boiling points and fractional distillation. That word is very important. You must mention the name of the process at least. Even if you don't give a detail, just mention that fractional distillation. It's a 2-mark question. We don't need to give a lot of detail. Like right now, it has more detail than it requires, but fractional distillation word is super important. Test for oxygen, we know we take a glowing splint. We don't take a burning splint, we take a glowing splint. The one that does not have an open flame and it relights. That's how we know it is oxygen. Ozone is formed in the atmosphere by reaction of nitrogen dioxide with oxygen in the presence of ultraviolet light. Say the type of chemical reaction that takes place when ozone is formed in this way. And now, because you're using ultraviolet light, it's a reaction which uses light. And those reactions, just like photosynthesis, this one's also photochemical reaction. Okay. If you don't want to use that, then you also know that nitrogen dioxide reacts with oxygen to form O3, right? So that's oxidation. You can also say it's a redox reaction. Nitrogen dioxide is formed in internal combustion engine. State one other source of nitrogen. So that is lightning. Basically, you need a very high temperature. Spelling that wrong. You need a high temperature for nitrogen to react because nitrogen has triple bond, which is very strong. It makes it unreactive. So lightning strike also provides that energy. A layer of ozone is present high in the atmosphere. State one problem for human that can arise if the ozone layer is depleted. So there is going to be, now do not say that sunlight will be able to come in or harmful rays will be able to come in, because we need to specify the problem that those harmful rays will cause. So that can be skin cancer or other skin conditions. It can harm the eyes, it can harm the skin or sunburn. Those are all possibilities. So skin conditions or skin cancer. That's a good enough answer. There is concern about the disposal of plastic made from non-biodegradable polymers. The partial structure is shown. So this is a non-biodegradable polymer. We know it's an addition reaction, and that's why it's not easy to disregard or to dispose of. Draw the structure of monomer used to make. So whenever we make a polymer, what do? We do RCJ. We remove the double bond, we combine whatever is made, and then we remove the double bond, we copy whatever is made, and then we join them. Over here, we have technically gotten through the RCJ method. So we will try to reintroduce the double bond. So the structure of monomer used to make. So just take this thing and just reintroduce the double bond. Now, how do I do that? I know that this is my repeating unit. So CH3 here, Cl here, hydrogen, hydrogen, and just introduce the double bond. And just take the repeating unit and introduce whatever you removed. This polymer is often disposed of by combustion. State one problem associated with this model of basically it has chlorine in it. So when it burns, it can provide HCl or other acidic fumes. So they can be poisonous, they can be toxic. So that's why we shouldn't do this. So the problem is that toxic fumes, those are the ones that are causing this. Lactic acid is used to make polylactic acid. Okay, so that is a biodegradable, which means it. So most of the condensation polymers are biodegradable. So we'll say that why is it biodegradable? It can be broken down naturally through the actions of bacteria. So bacteria are responsible for biodegrading. So it's a biodegradable can be. Moving on, draw the partial structure of polylactic acid. Now what you have to do is RCJ. So what will you remove? We will remove OH from one side and H from another side, and that is our repeat unit. Then we simply copy that part. So we copy that part and we make another one and we just join them. And there you go. That's how we get a polylactic acid. So 2 are good enough. Because we need to draw at least 2. You can make more if you want to, and just make sure that when you have this, you also draw the brackets to show that this is continuing. Even if you don't want to show the brackets, the bonds continuing on the side should be shown. Factory uses 500 tons of lactic acid to make polylactic acid. The percentage yield is 100%, but the mass is made is less than 500. Explain why the mass is made less. So the mass is made because you're also getting water that is a byproduct. So that is the reason that a byproduct, for example, in the case here is water, is also made. And obviously that has some mass in there. Aqueous lactic acid reacts with the acidic potassium manganate. 7, there's a color change. Okay, so that's redox. Say what happens to the lactic acid in this reaction. Because KMnO4 is oxidizing agent, we'll say it is oxidized. Aqueous lactic acid neutralized by sodium hydroxide. Write the ionic equation for neutralization. Now here's the thing. Whenever they ask you for ionic equation for neutralization, it has nothing to do with whatever is reacting, because neutralization is an acid which gives us proton reacting with alkali which gives us hydroxide making water, and that is whatever neutralization is. Doesn't matter what the acid is, what the base is. In this case, it is sodium hydroxide and lactic acid. It could be anything else, but as long as this is happening, it's neutralization. Aqueous lactic acid reacts with magnesium. Name the gas made in this reaction. So that gas is hydrogen. So name it. Do not write the formula, name it. Carbon is an important element. Carbon exists as isotopes carbon 12 and carbon 13. So let's just fill it up. This is a relatively easy question. Number of protons, because these are both carbon, it should be 6 and 6. Number of electrons, because they're neutral, 6 and 6. Number of neutrons, so subtract the mass and the proton number, so 12 minus 6 is 6 and 13 minus 6 is 7. Name two forms of the element carbon which have giant covalents, so those we know are graphite and diamond, and that's good enough. Do not say buckyball because buckyball has molecular structure. Avogadro's constant is the number of particles in 1 mole, that's the definition. The numerical value is this. Calculate the number of molecules in 22 gram carbon dioxide. Now, molecule is a unit, it's a particle on its own, right? And Avogadro's constant is number of particles. It's not number of atoms, it's not number of ions, it's number of particles. So particles could be anything. Right now they're asking us for molecules. So one carbon dioxide molecule is 1. So let's first figure out how many moles we have. So carbon dioxide's MR, I know, is 44, carbon is 12 and 2 oxygen 32. 32 plus 12, 44. So number of moles is going to be 22 over 44, that is 0.5. And now I'll multiply it by the number of the Avogadro's number, which is 6.02 into 10 power 23, which will give me 3.01 into 10 power 23 molecules. Okay. Calculate the number of molecules in 6 dm cube of carbon dioxide. Again, this is pretty straightforward. You know that you can use the ratio method or the formula, it's up to you. So you know that 1 mole, which has 24 dm cube, has 6.02 into 10 power 23. So in 6 dm cube, you're going to get x, cross multiply and you get your answer. If you don't like that, then of course, what we can do is, first find number of moles, that is 6 over 24, 0.25. Then multiply 0.25 with Avogadro's number, 6.02 into 10 power 23, and whatever the answer is, you can write that. Magnesium undergoes oxidation when it reacts with aqueous silver nitrate. We can see that. Explain how this equation shows that magnesium is oxidized. So just look at magnesium and how it changes. So over here it is magnesium and over here it's magnesium ion. That means it has lost 2 electrons. So it loses 2 electrons, and that's how it shows. The reaction of magnesium and silver nitrate is exothermic. Complete the energy profile diagram. So we start at some value, we go up for the activation energy, down, okay, and then we end at some value. This is exothermic because overall we are losing energy. They are asking us for energy profile diagram, so let me just label them. This is reactant, this is product. Activation energy is always, remember this, activation energy hoti hi starting point se top tak hai. It is the energy required to start a reaction. So that's this one. And if you're making an arrow, try to connect it to this top through a dotted line. So that is activation energy. Even though they did not ask us, they can. That's why I'm showing it to you. And now we need to show the delta H. So delta H again, it's from the starting point to the ending point. So that's this one. And I will also connect this one with the dotted line to show that this is delta H. And there you go. Acidifies aqueous silver nitrate. Okay, silver nitrate is added to a solution containing halide. We know silver precipitates are used to identify the halides. So yellow precipitate is also. So we have 3 halides in our syllabus: chloride, bromide, iodide. Now chloride is, we know, chloride is white, iodide is yellow. And we can infer from that because they are in the same group and they should show a trend, this should be off-white, some color in the middle of white and yellow. So take the name of halide present, because it's yellow, it is iodide. Now remember, don't say iodine because this is halide ion. Iodine ions are iodide. Silver is a metal used in knowledge of structure to explain why it is malleable. Why are metals malleable? Because they have layers that can slide over each other. So silver has layers of cations. You don't need to mention that, but sure, layers of cations which can slide over each other. The table gives information about thermal composition. Okay, we have carbonates, and you can see that it's easy to break down calcium carbonate, even easier to make for magnesium carbonate, and much difficult for sodium carbonate. It's no coincidence that sodium we know is the most reactive, calcium after that, and magnesium after that. in these three. So describe how the ease of this depends on the position of these metals in reactivity series. So you can clearly see that in reactivities, this is the first one, this is the second, this is the third. And in terms of how easy it is to decompose, this is first, this is second, and this is third, which shows a correlation that the more reactive the metal, less more difficult it is to break down the carbonate. So that's what we'll talk about. We'll say that more reactive this question is about iron. Okay, iron is extracted from its ore in a blast furnace. Okay, this is blast furnace, the structure. Name the main ore of iron used. So that is hematite. We know that. That's something we have to remember. So hematite. Name the substance that enters the blast furnace at A. So A is basically where you're getting hot air in, and that hot air comes in, basically oxidizes carbon. So this is air. Name the substance that leaves the blast furnace at B. Because iron is already mentioned, the other byproduct that we have is slag, which is basically CaSiO3. So you can name it, which is calcium silicate, or you can just mention slag. Okay, so slag or calcium silicate. Give 2 reasons for using coke in the blast furnace. So coke we use for a couple of reasons. Coke is an excellent fuel because it burns to provide a lot of energy, and that heats the whole thing up. Second thing we use it for is because coke can easily oxidize. It's a strong reducing agent, which means it takes the oxygen out of iron oxide, which is present in hematite, giving us iron out. And thirdly, because when you are getting carbon dioxide, you react with carbon to get carbon monoxide, which is a better reducing agent than carbon dioxide, at least, because carbon dioxide does not oxidize further. So because of this, coke has multiple reasons. So we can say that coke is used, we can use as fuel or reducing agent, or we have to mention what it reduces. So reducing agent for iron to oxide. Or the third thing we can mention is that it reacts with carbon dioxide to form carbon monoxide. You can even mention that it reacts with oxygen to form carbon monoxide. Okay, so you can even mention that. So reacts with oxygen or carbon dioxide to form carbon monoxide. Another ore of iron is iron pyrites. Iron pyrites contains the positive ion Fe2 plus. Deduce the formula of negative ion. Now here's the thing. If this is positive 2, the whole other thing, this whole thing should be negative 2. Okay, and that's what we'll have. Now there are 2 ways we can mention this. Either we can say it is S2 with the 2 negative charge, just like we sometimes say NO3 with 1 negative charge, right? The whole thing has a negative charge. Or if you don't like that, if you're like, no, wait a minute, this is not how it works. I know the cross multiplication method, so let me take 2 here and 1 here. So that gives me S minus 1. So you can even mention S minus 1. Both of them should be acceptable by the examiner. Iron is a transition element. The properties are shown. Give 2 properties from the list which iron differs from group 1 elements. So let's see, what does it make? Good conductor, group 1 can also be a good conductor. Soluble salt, group 1 is also soluble. Colored compound, that is showing it's different. Variable oxidation rate, catalyst, these 3. Any of these 3, you can just put them here. Give 2 properties which are similar. So obviously the other 3. It is basic oxide or conductor or soluble salt. So the other 3, you can mention this one or this one over here. Steel consists mainly of iron. Iron forms rust when it reacts. Okay, so what's happening here? You're using magnesium blocks. Magnesium is more reactive than iron. So जब ऑक्सीजन आएगी तो वो मैग्नीशियम से रिएक्ट करेगी, आयरन से नहीं करेगी, because magnesium is more reactive. So उसकी बारी पहले है. That is why this is sacrificial protection, and it makes sure that iron doesn't react, iron doesn't oxidize, iron doesn't rust. So how the magnesium blocks prevent? So सबसे पहले बात जो हमें करनी है that magnesium is more reactive than iron. So it oxidizes first, it reacts first, okay, not letting iron react. ठीक है. So अगर आपने first नहीं भी लिखना तो आप ये भी बता सकते हो that it oxidizes more easily, takes less energy to do that, any of those things. Okay, तो वो सारी बात clear हो जाएगी. Explain why replacing the magnesium blocks with copper blocks will not prevent them, because copper is less reactive. That's it. So copper is less reactive than iron. So copper के होते हुए तो iron नहीं react करना है, because iron is more reactive. Iron takes less energy to lose electrons or to react. So उसकी वजह से iron की rusting होगी, corrosion होगी, copper की नहीं होगी. So iron will be used to protect copper, which we don't want. Sulfamic acid is a white crystalline solid. What is sulfamic acid? Okay, this whole thing. It reacts with sodium nitrite to make nitrogen gas, as shown. Okay, an excess of sulfamic acid reacts with 20 cm cube. So because sulfamic acid is in excess, we'll just ignore it. Let's look at what we have left. So we have 20 cm cube of 0.15 mole per dm cube NaN2. So इसकी information लिख लेते हैं. So we have 20 cm cube and 0.15 mole per dm cube. ये इसकी information हमें मिल गई. Calculate maximum volume of nitrogen formed. So nitrogen information बतानी है. Okay, so let's use the traditional method that we have. सबसे पहले N equal to Cv for the acid, the nitrite. So that is 20 over 1000. Don't forget to divide by 1000 because this is in dm cube, needs to be converted into 0.15. तो इसका आंसर आ जाएगा 3 into 10 power minus 3. That's the moles of NaNO2 you have. अब मोल रेशियो को देखते हैं तो 1 mole of NaN2 produces 1 mole nitrogen. Mole ratio is 1 to 1. So that means 3 to 10 power minus 3 will provide 3 to 10 power minus 3. अब हमें वॉल्यूम देखनी है तो वॉल्यूम is moles multiplied by 24. So that's going to be 3 into 10 power minus 3 into 24. So 72 into 10 power minus 3 is 0.7072. Yeah. अच्छा, एक और मेथड भी है. We just copy that whole part. NaNO2 लिख लेते हैं, N2 लिख लेते हैं. अब इसकी मोल रेशियो देखो. This is salt, right? This solution. So solution में आप सिर्फ moles को देख सकते हो. So 1 mole of this produces 1 mole of this. और उसकी वॉल्यूम क्या है? 24. Okay? और इसके कितने मोल्स हैं? 0.15 into 20 over 1000. और इसकी कितने वॉल्यूम है? X. क्रॉस मल्टीप्लाई में गेट आंसर. तो ये भी बड़ा इजी मेथड है इसको सॉल्व करने का डायरेक्टली. The rate of this reaction can be determined by measuring the volume of nitrogen formed. So measuring the volume of nitrogen formed every second. दो चीजें measure करनी है, time and nitrogen की volume. Draw a label diagram for assembled apparatus that can be used to make, collect and measure. अब make कैसे करें? We are making it using these two things. One is a solid. Notice one is a solid and the other is aqueous. तो हमारे पास एक solution है और एक हमारे पास सॉलिड है. तो सबसे पहले हम क्या करते हैं, सॉलिड तो हमारे पास एक्सेस में था तो हम सॉलिड को डाल देते हैं इसमें कोनिकल फ्लास्क में. जब भी मिक्स करना होता है तो आप इस तरह से कोनिकल फ्लास्क यूज करते हैं. दिस इज योर सल्फैमिक एसिड. उसका फॉर्मूला क्या था? NH2SO3H. NH2SO3H. अच्छा, अब यहाँ पे हम सोल्यूशन डाल देते हैं. दिस इज योर NaN2 aqueous solution. अब इसमें से गैस निकलेगी. दैट गैस वी विल कलेक्ट यूजिंग गैस सिरिंज. Make sure the gas syringe has these markings to show कि ये measure करी. And बाकी को हमने क्या करना है? बाकी को हमने seal कर देना. Because we need to make sure कोई भी चीज़ escape नहीं करे. So yeah, this is a gas syringe mention कर देते हैं. Okay. और तीसरी चीज़ हमें क्या है? तीसरी चीज़ हमें चाहिए है time. Time को measure करने के लिए stopwatch. Okay, so stopwatch बनाने की ऐसा जरूरत नहीं है. This is good enough. We can easily do make, collect and measure the volume. ठीक है. The concentration of NaNO2 is increased, the temperature remains constant. State and explain how the rate changes. So concentration से क्या होता है? Concentration is how many particles you have in the same volume. That's what concentration is. So अब आपने particle ही ज़्यादा कर दिए. When you have more particles, they're going to collide more. When they're going to collide more, there's going to be more frequent collisions that are fruitful or successful. तो आपका rate increase करेगा. So we'll say that सबसे पहले हम state कर देते हैं. Rate increases. And then we explain why that is. Because increasing concentration increases the number of particles per unit volume. Volume की जिक्र जरूर करना है. Increases number of particles per unit volume. Making more frequent successful collisions per unit time. That's it. Sulfamic acid forms salts called sulfamates that contain the anion this. Magnesium carbonate is added to sample of this. Magnesium sulfamate, water and gas are formed. ठीक है, the gas turns lime water milky, that is telling me it is carbon dioxide. Construct the equation. So सही है, magnesium carbonate is added to this whole salt. Okay, now judging by the way this is reacting, it's producing magnesium sulfamate, water, carbon dioxide, and magnesium sulfamate का charge कैसे आएगा? इसका charge -1 है, उसका +2 है. So you just mention this whole thing, NH2SO3 with 2 and magnesium. You could cross multiply the charge. But an important thing to remember here is that this is a base and this thing is acting as acid. क्यों? It is giving the H positive out. और ये H positive जहाँ से निकलेगा इसकी जगह ये magnesium आ जाएगा. And that is how we are able to get this salt easily. So this is kind of a neutralization reaction in fact. क्योंकि यहाँ पर क्या हो रहा है? यहाँ पे कार्बन डाइऑक्साइड भी बन रही है, वाटर भी बन रहा है, सॉल्ट भी बन रहा है. This is acid base reaction. That's it. Okay. The structure of angelic acid is shown. Angelic acid over here, if you look at the structure, it's very interesting. We have double bond here, which makes it unsaturated, which means it can do addition reactions. अब addition polymers के लिए हो या addition reaction किसी और चीज के साथ हो, this is a potent site for that. And then it also has carboxylic acid group. Carboxylic acid group से हम ester बना सकते हैं. हम इसको यूज करके condensation polymers बना सकते हैं. हम इसको यूज करके इसको ये बना कैसे होगा? ये ऑक्सीडेशन ऑफ अल्कोहल से बना होगा. ये भी बात हो सकती है यहाँ पे. सो इंटरेस्टिंग, मल्टीपल homologous की प्रॉपर्टीज यहाँ पे नजर आ रही हैं. Explain how this structure shows that it is unsaturated. So it is unsaturated because it has carbon-carbon double bond. It's important to mention carbon-carbon double bond क्योंकि double bond खाली लिखेंगे तो वो तो कार्बन ऑक्सीजन की भी हो सकती है. उससे तो unsaturated नहीं होता. It is this bond that makes it unsaturated. Deduce the molecular formula. So just count all the atoms. So carbon I have 1, 2, 3, 5. Hydrogen is 3, 3, 6 and 2, 8 and 2 oxygen. Okay. Angelic acid is a weak acid. Define the term acid. So acid gives proton. So acid is proton donor or gives proton. Explain the meaning of the term weak. So we'll say it ionizes partially, it does not ionize fully, it is incompletely ionized. तीनों में से कोई भी बात कर सकते हो. So partially ionizes. Good enough. Angelic acid can be polymerized. State the name of the type of polymerization that occurs. अब एंजेलिक एसिड को अगर आपने एडिशन पॉलीमर करना है वो तो ये अपने तौर पे भी कर सकता है बिकॉज ये हैव डबल बॉन्ड. बट अगर आपने कंडेंसेशन पॉलीमर्स करना है तो आपको कोई अल्कोहल भी चाहिए, कोई चीज चाहिए जो H और OH में से एक चीज दे, क्योंकि ये OH या H तो दे देगा, बाकी चीज किसी और से आनी चाहिए. तो अगर इसको अपने साथ ही पॉलीमराइज करना है देन दिस डबल बॉन्ड इज गोइंग टू हेल्प. अगर आपने कंडेंसेशन पॉलीमर्स करना है आपको कुछ और चाहिए. क्वेश्चन में वो क्या कह रहा है? क्वेश्चन इज सेइंग एंजेलिक एसिड कैन बी पॉलीमराइज्ड. दैट मींस दिस थिंग ऑन इट्स ओन कैन बी पॉलीमराइज्ड. तो इसका मतलब है वो एडिशन पॉलीमर की बात कर रहा है, किसी और चीज को यूज ही नहीं करना है. ड्रॉ द पार्शियल स्ट्रक्चर ऑफ पॉलीमर ऑफ एंजेलिक एसिड. नाउ लेट मी रीअरेंज दिस थिंग. सबसे पहले हमने क्या करना है, हमने इस चीज को पकड़ना है और हमने इसकी डबल बॉन्ड को सामने रख लेना एंड एवरीथिंग ऑन द साइड जस्ट लाइक दिस वन. सो यहाँ पे CH3 है, हाइड्रोजन, CH3, COOH. दैट्स व्हाट आई डिड बिकॉज आई डोंट वांट टू ओपन इट ऑल अप. मुझे उसका फायदा ही कोई नहीं है. नाउ आई टेक दिस थिंग, इसको मैं यहाँ पे नीचे लिख लेता हूँ. ओके, अब करना क्या है, रिमूव कॉपी ज्वाइन। तो रिमूव क्या करेंगे, डबल बॉन्ड, कॉपी क्या करेंगे, जो भी बचा उसको कॉपी करेंगे, ओके, एंड देन विल जस्ट जॉइन इट। सो रिमूव कॉपी ज्वाइन, रिमेंबर दिस। सो ज्वाइन किया एंड वी नीड टू शो जस्ट टू रिपीटिंग यूनिट्स, तो वो तो बना दिए। नाउ यू हैव टू शो दीज बॉन्ड्स दैट दे आर कंटिन्यूइंग ऑन द साइड। ब्रैकेट लगाएं या ना लगाएं आपकी मर्जी, बट ये बॉन्ड बनाना जरूरी है। Angelic acid reacts with methanol to form an ester, ठीक है। Complete the structure of the ester shown to show all the atoms and all the bonds। अब यहाँ पे इंटरेस्टिंग बात ये है कि उसने एंजेलिक एसिड का पार्शियल स्ट्रक्चर दे दिया, उसने आपसे कहा खुद ही एस्टर बनाओ, खुद ही बताओ उससे क्या होगा, और वो चीज बना दो यहाँ पे। तो हम जरा देख लेते हैं। हमारे पास CH3OH है, एंजेलिक एसिड मेरे पास क्या था, एंजेलिक एसिड वाज CH3, यहाँ पे C था, डबल बॉन्ड थे, हाइड्रोजन, यहाँ पे CH3 था। इतना तो सामने नजर आ रहा है, दिस इज समथिंग दैट दे ऑलरेडी मेड। ऊपर क्या था, कार्बन विद डबल बॉन्डेड ऑक्सीजन और OH। अब ये वाला पोर्शन, दिस इज द पोर्शन दैट्स मिसिंग है, बाकी सब तो यही है, राइट, द होल थिंग इज मेड ऑलरेडी। सो व्हाट डू वी डू, हमारे पास दूसरी चीज क्या है, मेथनॉल। मेथनॉल को जरा लिखते हैं CH3OH। अब हमने रिमूव कॉपी ज्वाइन पढ़ा हुआ है, हमें पता है दैट रिमूव द H एंड OH। सो यहाँ से हम H रिमूव कर लेते हैं, यहाँ से OH रिमूव कर लेते हैं। इफ यू डोंट वांट टू डू दैट, यहाँ से OH रिमूव कर दो, यहाँ से H रिमूव कर दो, कर लिया। अब जब यहाँ से OH रिमूव होगा और यहाँ से H रिमूव होगा, तो फिर इनको ज्वाइन भी तो करना है। सो अब इसको ज्वाइन करेंगे, सो O एंड दिस CH3। अब लेट्स ट्राई टू कंपेयर दिस पार्ट विद व्हाट इज गिवन टू अस ऑलरेडी। हमारे पास ये पोर्शन है एंड दिस इज दिस पार्ट। द ओनली डिफरेंस इज CH3 को उसने ओपन करके दे दिया, which means we have to draw this part here with all the bonds, so no problem for us. Carbon, double bond, oxygen, CH3, और यहाँ पे हाइड्रोजन लिख लेते हैं, हो गया काम। तो ये नाम क्या होगा, मिथाइल, और साथ में आपके पास एक ब्यूटेनोएट या जो भी इसकी ब्रांच बनती है, मिथाइल भी है, एल्कीन भी है, कार्बन भी है। इसका नाम आपसे पूछेगा नहीं, ओके, बट आपको स्ट्रक्चर बनाना आना चाहिए। कर सकते हैं इक्वेशन फॉर कंप्लीट कंबशन ऑफ मेथनॉल। सो वी टेक मेथनॉल, बर्न इट, कंप्लीट कंबशन मींस कार्बन डाइऑक्साइड इज मेड। इनकम्प्लीट होती तो कार्बन मोनोऑक्साइड बनता है, या वो खाली कार्बन भी बन सकता था। नाउ यू बैलेंस दिस थिंग, हाउ मेनी कार्बन्स, 1 कार्बन, सो 1 कार्बन डाइऑक्साइड, 4 हाइड्रोजन, सो 2 वाटर। अब 2 वाटर आ गए हैं तो मेरे पास ऑक्सीजन कितनी, so 2 here and 2 here, that's 4 oxygen on the right side and how many on the left side। अब यहाँ पर देखने की बात ये है that I already have 1 oxygen here, so 4 में से एक तो यहाँ पर है, बाकी 3 यहाँ पे होने चाहिए। so उसको बैलेंस कैसे करते हैं, 3 on the right, 2 on the left, 3/2, that's the ratio, हो गया बैलेंस। अगर आप कहते हो नहीं फ्रैक्शन में नहीं लिखना, although examiner will accept fractions, लेकिन आप कहते हो कि नहीं मुझे फुल लिखना है, इंटीजर में लिखना है, double the whole, this becomes 2, that becomes 3/2 times 2 is 3, that is 2, and that thing is 4, and yeah, the equation is balanced. Petroleum provides a raw material for making ethanol and ammonia. Describe how petroleum is separated to make fractions such as ethanol. This is similar to what we saw in the very first question, second question about fractional distillation of air. So यहाँ पर भी do we need to liquefy it? No, it is already liquid. So अब हम क्या करेंगे, अब हम इसको हीट करेंगे, हीट करेंगे boiling point की बेस पर different fractions अलग-अलग हो जाएंगी। So we'll say that crude oil is heated and fractions separated based on boiling point in fractional distillation। अगर इससे भी ज्यादा डिटेल लिखनी है तो बता दो कि वो बॉइलिंग पॉइंट को कैसे यूज करते हैं। We know that when we heat this thing, the lighter fractions they move up, कॉलम होता है ना, इस तरह से बड़ा सा एक लंबा कॉलम होता है, यहाँ से आप उसको हीट कर रहे हो, जो बिल्कुल लाइट मॉलिक्यूल्स हैं, छोटे मॉलिक्यूल्स हैं, वो इधर टॉप पे कलेक्ट हो जाएंगे, तो हैवी है वो नीचे हैं, जैसे जैसे MR बढ़ता जाएगा वो इधर आता जाएगा। और MR और बॉइलिंग पॉइंट का आपस में भी ताल्लुक है, दैट लाइटर द molecule, lower the boiling point in this case, which means it will also go up. So you can also say that lower boiling point things are collected from the top and heavier things are collected at the bottom, or higher boiling point things are collected at the bottom. Compounds such as C11H24 in naphtha are cracked. Cracking was you heated hydrocarbons without oxygen to make smaller fractions like hydrogen, alkanes, alkenes. Explain how molecular formula shows the compound is alkane. So हमें कैसे पता है कि ये alkane है? So we'll talk about the general formula. So we'll say that alkanes have general formula. CnH2n plus 2. So C11H24 follows the formula or fits the formula. Construction equation show cracking. अब cracking में से आपने क्या बनाना है? Ethene and an alkane only. तो मैं जरा ethene बना लेते हैं. That gives me ethene is C2H4. तो C2H4 माइनस करेंगे तो हमारे पास क्या बचेगा? C2H4 माइनस करते हैं तो C9H20 बच जाएगा. आप कहते नहीं, मैंने ये नहीं करना, मुझे ज्यादा एल्कीन बनाने हैं. आप कहते हो मुझे 2 बनाने हैं. ठीक है, अब 2 C2H4 कर लो. अब इसका मतलब है आपने 4 कार्बन और 8 हाइड्रोजन निकालते हैं. तो 4 कार्बन निकलेंगे तो C7 बच जाएगा और 8 हाइड्रोजन निकलेंगे तो C816 बन जाएगा. आप 3 भी कर सकते हो, 4 भी कर सकते हो, 5 भी कर सकते हो. बेसिकली एज मेनी एज यू कैन टू मेक श्योर कि आपके पास बाकी चीज एल्केन रहे. ठीक है. नाउ आई एम नॉट श्योर कि मैक्सिमम कितना आप कर सकते हो, बट वो आप प्रैक्टिस करके देख ही सकते हो. Describe how hydrogen is converted into ammonia in the Haber process. Okay, hydrogen. Wait a minute. You can actually just make 5 more because 5 times C2 will be 10. So 10 carbon निकलेंगे तो पीछे CH4 ही रह जाएगा. Describe how hydrogen is converted into ammonia in the Haber process. Include the condition. So सबसे पहले तो हम describe करना है ना, तो हम उसकी equation लिखने की बजाय बात sentence की फॉर्म में कर देंगे. So we'll say that nitrogen and hydrogen react at 450 degrees Celsius, 200 atm pressure, and using iron catalyst. सारी बात होगी, डिस्क्राइब करना था ना, कर दिया बस. स्टेट 1 is the use of hydrogen. So हाइड्रोजन का यूज क्या है हमारे पास? हाइड्रोजन से हम फ्यूल सेल में बिजली बनाते हैं, हाइड्रोजन को बर्न करते हैं रॉकेट फ्यूल के लिए, और हाइड्रोजन से मार्जिन बनाते हैं. ये 3 यूजेस हमने पढ़े हैं, तो हम इनमें से कुछ भी बता सकते हैं. Ethene reacts with compound to make ethanol. Name the compound. So ethene, which is this thing, needs to something to make ethanol. So notice what's the difference? The difference is H and OH. And what is that? Water. So we'll say water. Name करना है, formula लिखना. State 1 condition, high temperature. ठीक है, 300 डिग्री सेल्सियस टेम्परेचर होता है एंड कैटलिस्ट होता है फॉस्फोरिक एसिड. बट नाम ही लिखें, ये जनरल लिख सकते हैं. IGCSE people need to know the conditions exactly. 60 atm pressure, 300 degree Celsius temperature, and phosphoric acid catalyst. And yeah, that brings us to the end of this paper. If you have any questions, feel free to discuss in the group. All right. Good luck.